Welcome to this explainer on agentic AI. Look, if you've been following the AI space lately, you already know the era of those basic prompt and response chatbots. Yeah, it's completely over. We are moving so fast into a world where AI actually executes complex, autonomous workflows. So today, we're demystifying exactly how you build these self-directed systems using the LangGraph framework. Just imagine having an AI that doesn't just answer your questions, but actively solves real-world problems for you. Our agenda today takes us right from the evolution of AI directly into the architecture of your own autonomous systems. We'll start with a shift to agentic AI, look at why you should choose LangGraph, break down its three core components, and finally, build your first graph. Okay, Section 1. Welcome to Agentic AI and the evolution to Level 3. Let's look at the timeline to understand exactly why we need these new coding frameworks. We have evolved insanely fast. Level 1 gave us basic conversational chatbots. You ask a question, it gives you an answer. Then Level 2 brought reasoning models like OpenAI's O1, which used chain of thought to act kind of like a PhD student intensely researching a topic before getting back to you. But Level 3, agentic frameworks, that is the massive paradigm shift. This is where AI moves from just thinking about a problem to autonomously acting on it out in the real world. So at this third level, we're basically building wrappers around large language models so they can make their own decisions. Think about it. If you give an agentic framework a really complex task, it doesn't just spit out one single answer and give up if it gets it wrong. No, it checks its own work. It can call external APIs and literally loop the task 50 times if it has to, refining its approach until the goal is fully achieved. It's an entirely self-directed system. Moving to Section 2, why choose LangGraph? It's really the ultimate tool for multi-agent workflows. You might be wondering, with great frameworks like Crew AI and AutoGen out there, why is LangGraph rapidly becoming the enterprise choice? Well, it all comes down to granular control. LangGraph gives developers unparalleled, low-level command over stateful, multi-actor workflows. And it doesn't drown you in heavy dependencies. It literally only requires LangChain core. Plus, the developer experience is just fantastic. It natively supports streaming outputs token by token, so you can actually watch your agent's brain working in real time. Oh, and it syncs flawlessly with Langsmith for deep dive debugging when things get complicated. To put it in perspective, think of traditional linear application code like an old-school rigid GPS. If a bridge is out, it completely panics and the whole application just stops, often crashing over a single missing comma. LangGraph operates on dynamic cycles instead. It's like a modern smart GPS. If it hits an obstacle, it doesn't crash the car. It independently reroutes, backs up, or loops through the process as many times as needed to actually reach your destination. This dynamic routing is what unlocks LangGraph's actual superpowers. First, cycles and branches let you easily build complex logic loops. Second, it has built-in persistence, which means it auto-saves states after every single step. That gives you incredible fault tolerance if, say, a server drops. And finally, my absolute favorite feature, human in the loop. Your AI can run completely autonomously, but it can actually pause itself to ask you for permission before doing something risky, like swiping a credit card or pushing code to production. All right, Section 3, the three core components. Let's break down the blueprint. If you want to build any autonomous workflow imaginable, you really only need to master three foundational pieces. Our first building block is state. Think of state as the shared memory, or maybe the central nervous system, flowing continuously through your application. In Python, this is usually just set up as a simple typed dict. As your agent works, the state carries the original prompt, catches any intermediate data, and holds the final output. It's constantly being updated by a reducer function as it moves from start to finish. Our second block represents the nodes. If the state is the memory, nodes are the actual workers, the business logic of your application. In practice, a node is just a Python function. It takes the current state, performs a highly specific action, maybe pinging an LLM, searching the web, or using a calculator, and then it seamlessly updates the state with its shiny new findings. The final block here is the edges. If nodes are the destinations, edges are the roads connecting them. Now, a simple edge is just a fixed path. Node 1 always goes straight to node 2. But the real magic happens with conditional edges. These act as dynamic decision makers. They evaluate the current state and mathematically decide, hey, do we route to node 2, skip ahead to node 3, or loop all the way back to the beginning and try again? Which brings us to Section 4, building your first graph and wiring the pieces together. We've got the theory down, but seeing how these snap together programmatically in Python is where it actually gets fun. Assembling the graph follows 5 really logical steps. You define your state schema, add your logic nodes, draw the routing edges, compile the graph, and finally invoke the flow. Let's look at how this translates directly to your code editor. So, steps 1 and 2. First, you initialize your state schema. You're basically defining the exact variables that will live in your network's memory, like a string for the user's prompt. Then you initialize your state graph object with that schema, and literally use a simple add node command to drop your custom Python functions right into the graph environment. Right now, your nodes are basically isolated islands. They exist, but they have no clue how to talk to each other. That's where step 3 comes in, drawing the map, using the add edge function. You meticulously define the journey, connecting the framework's special start node to your first piece of logic, wiring your nodes together, and eventually pointing the final output to the framework's end node. Step 4 is compilation. By calling the compile method, LangGraph takes your custom blueprint, runs a quick sanity check for structural errors, and locks it into an executable object in memory. This is such a crucial step because it turns your loose definitions into a highly optimized, ready-to-run powerhouse that won't just randomly break on you during runtime. Finally, the moment of truth, execution. You use the invoke method, pass in your initial prompt, and boom, it kicks off the autonomous routing. The data enters the start node, gets processed by the LLMM, makes autonomous routing decisions on the fly, loops if it hits an error, and finally delivers the refined result right at the end node. By breaking everything down into states, nodes, and edges, LangGraph takes the dizzying complexity of level 3 agentic AI and turns it into a really approachable, elegant process. The flexibility here is truly limitless. I mean, you can build anything from a simple self-correcting calculator to a massive multi-agent enterprise research team. You've got the blueprint now. So the only question left is, what autonomous agent will you build first? Thanks for joining me on this explainer, and happy building.